Hello, this is a talk through of the Unit 2 higher tier specimen paper for CCEA GCSE chemistry. So, question 1. The study of organic compounds is simplified by grouping the compounds into homologous series. What is meant by the term homologous series? So, it means the same general formula, with similar chemical properties, a gradual change in physical properties, and each differs by a CH2 group. There's a maximum of 3 marks there for that, so any 3 of those points. Part B. Butanoic acid is a weak acid. It behaves as a typical dilute acid. Write the molecular formula of butanoic acid. So we have 4 carbons, so it's 1, 2, 3, 4, and then the double bond O and the OH on the end, and then you fill in your hydrogens. When we write that out, you can either write CH3, CH2, COOH, or C3H7, COOH, because we always write the acid group as COOH. Then draw the full structural formula. Well, here it is. We have our 4 carbons, the acid group at the end, and then the 7 hydrogens around it. Next, some copper carbonate was added to a warm solution of butanoic acid with stirring. Write a balanced symbol equation for this reaction. So, copper carbonate, CuCO3. The butanoic acid is here. And then, because copper is a +2 ion, and this is just losing a hydrogen, you need 2 of the butanoate ions to join to the copper. So it's C3H7COO in brackets with a 2 on the outside, Cu. And then because it's with a reaction with carbonate, you get water and carbon dioxide. So where that's marked, you get 1 mark for the correct formula of the reactants, 1 for the correct formula of the products, and then balancing is 1 mark. Next, describe what you would observe when copper carbonate reacts with butanoic acid. So you have a maximum of 3 here, and any of these points will get you a mark. So saying it's a green solid, which disappears, so if you said the solid disappears, bubbles or fizzing or effervescence or a gas being evolved, anything like that, it's just 1 mark. Heat given out, 1 mark, and a blue solution forms, and you could guess that because it's copper. Copper always gives you sort of a blue solution. Sometimes bluey green, but just go for blue if you're not sure. So a granule then of zinc metal was added to a solution of butanoic acid. State the name of the gas given off during this reaction and describe a test which would be carried out to confirm the presence of this gas. So state the name is hydrogen, and then the test for the gas, you need to say something about put a lit splint in it, or I've just said a lit splint burns, and then with a squeaky pop. So a popping sound is what it says on the mark scheme, but I'd always say squeaky pop. Number 2, nitrous oxide N2O, also known as laughing gas, is commonly used as an anaesthetic in dentistry. Nitrous oxide may be produced by heating a sample of ammonium nitrate, which is NH4NO3. The equation for the reaction is given below, and you see it here. Calculate the volume of nitrous oxide which can be produced when 2 kilograms of ammonium nitrate are fully decomposed on heating. So state the units as well. So we're told in the questions 2 kilograms of the ammonium nitrate. So 2 kilograms is 2,000 grams. So you need to convert that to begin with. Then you work out the formula mass of the ammonium nitrate. So 2 nitrogens, 4 hydrogens, 3 oxygens. That gives you a total of 80. The number of moles is mass divided by the formula mass. That's 2,000 for the mass, 80 for the formula mass, which gives you 25 moles. Now looking at the equation, we can see that 1 mole of the ammonium nitrate gives us 1 mole of nitrous oxide. So it's a 1-to-1 ratio, and that means that the number of moles of nitrous oxide is 25. You're asked for the volume of the nitrous oxide, so we know that 1 mole is 24 dm cubed, so 25 moles is 600 dm cubed. So you get 1 mark for the 600 and 1 mark for the dm cubed. The other marks there are coming from the mass, changing that to 2,000 grams, and getting to 25 moles, and then the volume of the nitrous oxide, you're getting a mark for multiplying by 24. And then a mark for 600, mark for dm cubed. I've left one out somewhere. Yep, the number of moles of nitrous oxide as 25. So there's 6 marks in that question, and that's where they come from. B. Nitrous oxide may also be produced by heating ammonia and oxygen in the presence of a catalyst. The equation for this reaction is given below. State Avogadro's law. So 3 marks for this. The first mark is for saying that equal volumes of gases. Second mark under the same conditions of temperature and pressure. And then the third mark is for saying they contain the same number of moles, or you could say same number of molecules or same number of particles. So 3 marks, 1 for each of those 3 points. Then using Avogadro's law, or otherwise calculate the volume of ammonia in cubic centimetres required to produce 70 cubic centimetres of nitrous oxide. So if we just look back to the equation, you'll see that in there we have 2 moles of ammonia giving us 1 mole of nitrous oxide. So it's a 2-to-1 ratio. So we're just simply multiplying the number of moles we got before, or in the question, or the number of cubic centimetres, in the question, which was 70, by 2, which gives us 140 cubic centimetres. So 1 mark for multiplying 70 by 2 and 1 mark for the answer of 140. Next, calculate the atom economy for this reaction to produce nitrous oxide. So in the reaction, we're looking at what is the useful product. In this case, it's the nitrous oxide, and then the mass, the total mass on the right-hand side. So nitrous oxide is 44. The total mass of the products, that when you add the 44 to the 3 moles of water, you get 98. So it's 44 divided by 98 times 100. So 1 mark for the 44, 1 for the 98, and then your third mark is for the answer, 44.9%. Alright, number 3. The electrolysis of molten lithium chloride may be carried out using the apparatus shown below. Molten lithium chloride is the electrolyte, and we've got the circuit with electrode A, electrode B, the molten lithium chloride sitting on a tripod being heated. So what's meant by the term electrolyte? And I've forgotten to fill this one in. So it's just a liquid or solution. That would be for your first mark. That conducts electricity. Well, it nearly says electricity. And is decomposed by it. In other words, it's decomposed by the electricity. I'm going to have to fix the spell in there, that will annoy me. Okay, so name electrodes A and B. So you can see here A is on the positive side, B is on the negative side. So that means that A is the anode and B is the cathode. What materials used to make the electrodes? Well, you would know graphite. If you said carbon, that's okay instead of graphite. Or you could also say platinum. And a reason why it's used to make the electrodes, well, you just need to say something about it being unreactive. Inert is always a good word to use. Or you could say it's a good electrical conductor. Only 1 mark for that, so either of those. Then at which electrode, A or B, is the lithium produced? So we know that lithium's positive. The negative electrode is the cathode, so it's B, or you could write cathode there. What would you observe at the other electrode? Well, you would see bubbles and you would see a green gas. Now, the mark scheme does accept green or green-yellow or yellow-green, but I would just stick with green for chlorine always. Then write the half equations for the reactions which are occurring at each electrode. So if the lithium's produced at B, then chlorine's produced at A. So we're looking here at Cl minus giving us Cl2, and that then is we're gonna need 2 chloride ions, and we're gonna get 2 electrons. The way it's marked, there's 1 mark for the Cl minus going to Cl2, 1 mark for the electrons on the right hand side being plus electrons, and 1 mark for the correct balancing. And then the next one is just Li plus the lithium ion plus an electron gives you lithium, and the first mark is for the Li plus going to Li, and the second is for the electrons plus electrons being on the left hand side. You could write them the other way around. For the first one you could have 2Cl minus minus 2 electrons gives you Cl2, and for the second one you can have Li plus giving you Li minus an electron. But it's easier to make sure you just write the electrons as plus. Makes it easier for the examiner to see. Okay, number 4. Hydrogen gas was produced in a laboratory by reacting zinc metal with hydrochloric acid. Draw a labeled diagram of the assembled apparatus used to produce and collect several gas jars of hydrogen using the reaction of zinc metal with hydrochloric acid. There are a number of ways you could do this, and the mark scheme is not very precise. It just says the production for 1 mark. You have to have the zinc and hydrochloric acid in contact. So you see I've got that here, so that would be 1 mark for me with that. The second mark is for saying in a suitable container. So I have a conical flask there. You could have a boiling tube or something else as long as you had a stopper in the top. And then another mark is for having a delivery tube or some sort of way of the gas getting into the gas jar. And then finally the final mark is for the gas being collected over water. So there I've got a gas jar sitting on top of a beehive in a trough, and the delivery tube is coming up through that, and then the hydrogen is being collected by downward displacement of the water. So 4 marks there for those 4 things. Then hydrogen gas may be used as a fuel and is described as a clean fuel. Explain what you understand by the term clean fuel. It simply means it's a fuel that doesn't pollute. So if you say it doesn't produce pollutants, either in combustion or when it burns, you could say. Alright. Part C, the equation for the reaction of hydrogen with oxygen is 2H2 and O2 gives you 2H2O. Bond energies are shown in the table below. So you've got the bonds here and then the energies here. Then calculate the energy change for the reaction of hydrogen with oxygen. So we're looking first at the bonds broken. We have 2 bonds in the hydrogen here. Each hydrogen molecule is looking like this. So we have 2 of those. So 2 bonds, 2 times 436. The oxygen is a double bond, so it's 1 of those, and that's 498. So the total on the left hand side is 1370. Then on the right hand side we're making water, so each water molecule has 2 OH bonds. So in total we have 4 of those OH bonds, 4 times 464, which gives us on the right hand side 1856. So the overall change then is the bonds broken, 1370, take away the bonds made, 1856, and the overall total then is minus 486. And the way it's marked, there's 1 mark for the energy required to break the bonds, there's 1 for the energy you get when the bonds are made, and then there's 1 for your overall answer. Now, part 2. The reaction of hydrogen and oxygen is exothermic. Draw a labelled reaction profile diagram for this reaction, including activation energy. So what the mark scheme says here is axes correctly labelled. So I've got energy on the y-axis and time on the x-axis. So that would be 1 mark. The second mark then is for having activation energy correctly labelled. So it's this distance here. And I've labelled it there, so that would get me my second mark. And then the third mark is for having the products at a lower energy than the reactants. And that gives you your third mark. So you could well be asked to draw one of those. Of course, endothermic, you're just doing it the other way around with the reactants below the products. So number 5. Approximately 3/4 of all elements are metals. A student decided to determine the order of reactivity of the metals copper, magnesium, nickel and zinc. Each metal was placed in a solution of the metal chloride of each of the other metals. The reactions are shown in the table below. So if we look at the table, copper going into magnesium reacts. It also reacts with nickel. It also reacts with zinc. We put magnesium in, there is no reaction with anything. With nickel, there is a reaction only with magnesium and zinc, but there's no reaction with copper. And finally, with the zinc chloride, there's only a reaction with magnesium, but not with nickel or with copper. So putting those into order of reactivity then, copper reacts with everything, so it's the least reactive. Magnesium reacts with nothing. The magnesium chloride reacts with nothing, so it's the most reactive. And then the zinc reacts with 1, and the nickel reacts with 2. So if we look at it from the point of view of the metals and their reactions, I maybe haven't been terribly clear there. So the metals, copper has no reaction at all with anything. Nickel, next least reactive, then zinc, and then magnesium, you can see, displaces all of the other solutions. So your answer, magnesium, zinc, nickel, copper. Next, the reaction which occurs when magnesium metal is added to copper chloride solution may be represented by the half equation. It's Mg plus, or Mg gives you Mg2 plus and 2 electrons. Explain in terms of electrons why this is an oxidation reaction. So the first thing I would say is that oxidation is loss of electrons, and that would give me 1 mark. And then to say that magnesium is losing 2 electrons to form a magnesium ion, that's the second mark. B, then, the method used to extract a metal from its ore is related to its position in the reactivity series. What method is used to extract aluminium from its ore? Well, it's electrolysis. And the name of the ore from which aluminium is extracted is bauxite. Now this is a very long question. I don't think I've seen one as long as this in the actual exams, but you just never know. So it says, in industry, iron is manufactured in the blast furnace. Describe in detail the process used to extract iron metal from its ore in the blast furnace. You can see here at the bottom 12 marks, so you need to be careful as to where you're getting the marks from. So it says you need to include the names of the raw materials and then at least 3 balanced symbol equations for the stages of the process, including the production of the reducing agent, the reduction of iron ore, and the removal of impurities. So we'll start off with the raw materials. And there's actually a maximum of 3 according to the mark scheme for the raw materials. So you could have 4. You have hematite, or you could say iron 3 oxide. You have calcium carbonate. You could also call it limestone. You've got coke, or you could say carbon, and you have hot air. So a maximum of 3 of those. And then for the equations, so you're asked for the production of the reducing agent. So 2 equations for that. The first one is carbon and oxygen giving you carbon dioxide, and the second then is the carbon dioxide reacting with more carbon to give you carbon monoxide. Then the reduction of iron ore, so iron ore is Fe2O3, and the reducing agent is carbon monoxide, so plus 3CO gives you 2 Fe and 3 CO2. And then the removal of the impurities. So first the calcium carbonate decomposes to give you calcium oxide and carbon dioxide. And then the calcium oxide CaO reacts with the calcium or the silicon dioxide SiO2 to give you calcium silicate. So how are these marked? Well, the first equation there is simply worth 2 marks. There's no balancing involved in it, so I imagine it doesn't actually say in the mark scheme, but I imagine you're getting 1 mark for the reactants, 1 for the products. Then the next one is 3 marks. So again, I would say 1 for the reactants, 1 for the products, and this time it's balanced, so you're getting a 3rd mark there. The third one then is also worth 3. Again, I would say because of the balancing that's involved in that. The 4th equation is just worth 2, as is the last one, and you can see here both of those don't require balanced at all. So that seems to be the way they've decided to mark it. And it's a good rule of thumb in an equation: 1 mark for reactants, 1 for products, and 1 for any balancing that needs to happen. So you see there, you have 3 from the first part of the question, and then 2, 4, 6, another 12 from the bottom part. So they've said that there's a maximum of 8 here for the second bit. So actually the total maximum that you can get for these marking points is 11. And the way it's marked, they've said in the bands that a minimum of 11 marks from the indicative content, including 3 balanced equations, would be in the band of 9 to 12 marks. So basically if you're getting 11 points, you're going to get 12. Now the final mark is for a logical order of the reactions. So if you put them in the wrong order, you're going to do yourself out of a mark here or there. The second band, if you've got 6 points, you're going to be somewhere in the region of 5 to 8 marks, and they tend just to give you the top number in that band. And then in the last one, if you've only got 2 indicative points, you're only going to get a maximum of 4 marks in that. It's quite complicated the way it's marked, but if you are faced with something like that, make sure you're reading what it tells you at the beginning that you have to include, and make sure you're including everything that you can for those. Okay, then phytomining is an alternative method used to extract metals such as copper from the Earth's crust. Explain how the process of phytomining can extract metals from the Earth's crust. So what they do is they plant the plants on top of an area which is rich in the metal but not high enough to make it viable to extract in other ways. So maybe, a rubbish dump or something like that, or I don't know, industrial waste, something. So what you need to say here is it uses plants to absorb the metal compounds, and the plants are harvested and burned, and the ash contains the metal compounds. And then the metal can be extracted from a solution made from the ash. So, like for example, by displacement. So you see there are 3 marks for that, and those 3 points. Then one advantage of phytomining, it's not like traditional mining, so you don't need to dig or move or dispose of large amounts of rock. So I think anything reasonable there really would get you a mark. Number 6, in industry, hydrogen gas is used in the production of ammonia gas. The reaction is reversible. What's the name given to the industrial process to produce ammonia gas? Well, it's the Haber process. And then a balanced equation, you should know this straight away, for the production of ammonia gas. N2 plus 3H2 gives you 2NH3. Again, 1 mark for the reactants, 1 for the products, and then 1 for your balancing here, so the 3 and the 2. Then complete the table, giving the operating conditions for the industrial production of ammonia gas. And I had done this, but it hasn't saved, so that's iron is the catalyst. The temperature used is 450 degrees C, and then of course the pressure is 200 atmospheres. So just make sure that you're using the units there as well, 1 mark for each of those. And then a study of equilibrium is important for understanding chemical reactions. Taylor's principle. So what you need to say is, if a change is made to the conditions of an equilibrium system, so you wouldn't just say if a change is made to the conditions, you need to say of an equilibrium system. And then, so that's 1 mark. The second mark is then to say that the position of equilibrium will move to oppose the change. And any questions about equilibrium, they love that phrase, to oppose the change. Okay, so 2 marks there. Right. Oopsies. Part C then. Okay, so we have different reactions here. The first one is hydrogen and hydrogen iodine, giving you hydrogen iodide. You see that it's negative enthalpy. So the next one, or the energy change, is negative. So the next one, carbon dioxide and hydrogen, giving you that's methanol and water. That's minus 49 as well. Then N2O4 giving you 2NO2. That's positive. 2SO2 and O2 giving you SO2SO3, negative. And the final one we have, that's ethene and water, giving us ethanol, minus 42. So just the one that sticks out there for me is R, because it's positive and the rest are negative, which means it's endothermic and the others are exothermic. So in each of parts C1 to C5, select one of the letters that represents the equilibrium reaction that best fits the information provided. You may use each letter once, more than once, or not at all. Show which one represents a decrease in temperature at constant pressure, or a reaction where, a decrease in temperature at constant pressure shifts the position from right to left. So you want it to go to the left, and, well, the one that I identified there was minus 58, so it's going to be R. It's the only one where the energy changes go in the right way. So then the equilibrium may be described as an oxidation reaction. You're looking for something which is reacting with oxygen. So the only one really that fits the bill there is S. Okay. So sulfur dioxide making sulfur trioxide is the only one where oxygen is being added. And a decrease in pressure at constant temperature shifts the position of equilibrium from left to right. So decrease in pressure. Now what we're looking for there then is something which, and it's actually R. So on the right hand side we have 2 moles of gas. On the left hand side we have 1. So decrease in pressure is going to allow it to compensate by moving to the right. So it's R. Part 4, there's no change in the position of this equilibrium when the pressure is increased at constant temperatures. You want something which has the same number of moles on each side. And there we have 2 moles on the left hand side of P and 2 on the right. So it has to be P. If you look at Q, there's 4 moles on the left, 2 on the right. R has 1 on the left, 2 on the right. S has 3 on the left, 1 on the right. And T has 2 on the left and only 1 on the right. And then 5, an increase in the concentration of steam at constant temperature and constant pressure shifts the equilibrium of this from right to left. So the only one where increasing the concentration of steam, there's only one with, well, there's 2 with steam in it. We have T there and Q, but the one that we want is with steam on the right hand side, which is Q. Sorry, it's stuck there for a minute. Right, number 7. In a laboratory experiment, 0.5 grams of magnesium ribbon with excess dilute hydrochloric acid at room temperature were reacted. The volume of gas produced was recorded every 20 seconds. The results obtained in the experiment using 0.5 grams of magnesium ribbon and excess dilute hydrochloric acid are shown as line C in the graph below. So we can see that there. And it says use the graph to determine the time taken for the reaction to finish. So we're looking for when it becomes flat, and you'll see it's just there. And when you follow that line down, you'll see that that is at 76 seconds. Now the mark scheme does allow for plus or minus 2, so it allows between 74 and 78. Then calculate the rate of this reaction. Rate is 1 over the time. It's 1 divided by 76, which is 0.013. So 1 mark for each part of that. And of course, if you used a different value here of 74, 75, 77 or 78, they would still allow you the correct answer, consider as long as you worked it out properly. Now we've got the reaction. The experiment was repeated using different conditions, and the results obtained plotted lines A, B, D, and E in the graph. Line C shows the original experiment. I'm just going to highlight it here. Of 0.5 grams of magnesium ribbon and excess dilute hydrochloric acid. So they're going to ask what the other lines are, I imagine. So state and explain which of the lines would have been obtained if the 0.5 grams of magnesium ribbon were replaced with 0.5 grams of magnesium powder. So what you're looking for is somewhere then one of the graphs that is going to be at the same height but going faster, so that can only be D. And the answer then is D. So that's your state, and then explain. Well, the increased surface area gives a faster reaction, so that's for 1 mark. And then your second mark, it's the same mass, so it finishes at the same volume. That's your second mark there for your explanation. Next, which one would have been obtained if it was done below room temperature? So if it's below room temperature, it's going to go slower, and the one which is slower here is B, but it also goes up to the same volume. So just your answer there is B. And then which one if it was 0.25 grams? And you can see here on this little graph, I'm just drawing stripes everywhere. So you can see here you're looking for half the mass, and if it's half the mass you're only going to get half the volume, so that's A. And it asks for an explanation, so in this case you've only one for the explanation, so the mass used is half, so half the volume of gas will be produced. And this is the final question then, part C. A catalyst may be used in some reactions. In an experiment to find a suitable catalyst for a certain reaction, the following results were obtained. The temperature and all other conditions were kept the same. So we have different catalysts: cobalt chloride, 15 seconds, cobalt nitrate, 12 seconds, potassium nitrate is 41, and sodium chloride is 56. And it says which substance is the best catalyst. So you're looking for the shortest time, which is this one, which is the cobalt nitrate. So your answer there, the substance is cobalt nitrate, and your explanation is simply that the reaction was the fastest. So that's it. Hopefully you'll not get anything as long as that awful 12-mark question, but this should give you an idea of the sort of thing that could come up in Unit 2.